awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hi and Assalamualaikum to all students. Welcome back to my channel. So for this video, we're going to discuss some examples that related to chapter 3. Okay, so we have 6 examples to discuss, and all the questions is the combination of all subtopics that have been discussed in chapter 3. Okay, so I hope these extra examples can help you to do more exercises in order to understand this chapter. Alright, so now let's try to answer example number 1. So here we have two lights bulb, P and Q, where P absorbs 60 watt power and Q absorbs 100 watt of power, okay, when connected to a 240 volt power source. Okay, so determine the bulb that has greatest resistance. Okay, so we want to calculate which bulb has the greater resistance. Okay, either bulb P or bulb Q. Okay, so now let's take out all informations that given by the question. Okay, so let's write question number example number 1, okay, which is A1. Okay, so let's say we have a battery here. So this is the power source, which is 240 volt, and this is the bulb. Okay, so I label this as P, and this is 240 volt. Okay, and this is Q. Okay, so this is Q, and this is also 240 volt. Okay, and we can calculate what is the value of the power that supplied to the bulb. Okay, based on the question, okay, we can write that power P is equal to IV. Okay, so since we want to calculate the resistance in each bulb, P and Q, so I will write I is equal to V over R. So it's from equation V is equal to IR. So I is equal to V over R. Okay, so therefore, we're going to have another equation. So power dissipated in bulb P is equal to V squared over RP, where RP is the resistance in bulb P. And for Q, we are going to write PQ is equal to V squared over RQ. Okay, now we can substitute the value of the power that absorbed by bulb P and the power that absorbed by bulb Q. Okay, so the power absorbed by these two bulbs is actually the power dissipated in bulb P and Q. So for P, the power is 60 watt and the power source is 240 volt. Okay, the voltage supplied to the bulb squared and RP. Therefore, RP is equal to 660 ohm. Okay, so this is the answer. Okay, and how about Q? So same method. So we have PQ is 100. So this is given by the question, and 240 squared, and RQ, we want to find what is RQ. Therefore, RQ is equal to 576 ohm. Okay, jangan salah unit. So this is the answer. Okay, so based on the answer, bulb P has greater resistance than bulb Q. Okay, so this is our answer lah. Okay, for the second part, what will happen to the power dissipated in a resistor if the voltage across the resistor is double? Okay, so before we double the voltage of the resistor, I'm going to write initial condition. Okay, initial conditions means that P is equal to V squared over R. Okay, means that before we double the voltage, So power is equal to V squared over R. When we talk about the power dissipated in a resistor, you must use equation P is equal to V squared over R. Okay, we need to relate the voltage, okay, that's supplied to the resistor with the resistance R. Okay, so what happened? Okay, let's say I put the final condition. Okay, the final condition now where V prime, so V prime stands for the voltage after we double the voltage, which is the final voltage. So V prime is equal to twice ataupun double of V, so 2V. Therefore, P prime is now is equal to V prime squared over R. So we have V prime is equal to 2V and it's squared over R. Okay, so now P prime is equal to 4V squared over R. Okay, look at here, we have V squared over R, where V squared over R here is P. Okay, sorry, which is this is P. Okay, therefore P prime, which is the power dissipated in a resistor after we double the voltage across the resistor, is equal to 4P. Okay, which is P prime is increased by a factor of 4. Okay, so we can write here, this means, okay, this means that, okay, if the voltage across the resistor is double, okay, so the power dissipated okay, the power dissipated, okay, in the resistor ataupun the power dissipated in it increase by a factor of 4. Okay, so kita boleh tengoklah the power dissipated akan increase 4 kali ganda compared to the initial condition. So bila kita doublekan dia punya voltage across the resistor, then the power dissipated also increase. Okay, alright, good. Okay, so now let's proceed to question B. Okay, so for question B, so we have a battery where the EMF of the battery is 3.0 volt, okay, and the internal resistance is 5.0 ohm, and it's connected to a switch by a wire of resistance 100 ohm. So now the voltage across the battery is measured by a voltmeter. So what is the voltmeter reading when the switch is off and on? Okay, so let's draw the circuit. So let's say this is the battery and this is the internal resistance. Okay, and let's say this is the switch. Okay, and let's say this is the resistance of the wire. Okay, so this is the resistance of the wire. So I just put this as the R wire. So we know that the wire of the circuit has the resistance of 100 ohm. So this is given by the question. Where the EMF, okay, so this is the EMF. So this is the battery. Okay, so the EMF is given as 3.0 volt. Okay, and the internal resistance is also given, so it's 5 ohm. So R is equal to 5 ohm. Okay, so now what happened? Okay, what is the value or the reading of the voltmeter when the switch is off? Okay, means that we have a voltmeter and we try to attach the voltmeter here. Okay, so the voltmeter, we read the reading of the battery. So since the switch is off, okay, so no current flow through the circuit. So we can write that the reading of the voltmeter will exactly equal to 3.0 volt. So for 1, so when the switch is off, okay, so no current flows where I is equal to 0. Okay, so no current flows through the wire and no current flows through the internal resistance. Okay, so we can write that no current flows in the circuit. Okay, hence the reading of the voltmeter is equal to 3 volt. Since the question gives us that the EMF is equal to 3.0 volt, so when switch off, so this is S, okay, so here is S. So when switch off, so it means that the reading of the voltmeter, the reading of the EMF, which is 3 volt. Okay, and what happened when the switch is on? Okay, so what happened when the switch is on? Okay, so now when switch on, okay, so let's draw. Okay, so this is R wire, R, and this is EMF. So what happened when switch is on? There is current flow in the circuit, okay, where the value of current I, okay, is the same value of I that passed through the resistance of the wire, R, and also the same value of current that passed through the internal resistance. Okay, so we want to calculate what is the reading of the voltmeter. So now we want to calculate what is the reading of the voltmeter here. Okay, so the voltmeter, okay, the voltmeter we read, so let's say we put here, okay, so the voltmeter we read the voltage. Okay, so the voltmeter will show you the reading of the terminal voltage, which is Vt. Okay, so we can write that EMF is equal to terminal voltage plus voltage that across the internal resistance in the battery, VR. Okay, so now we want to find what is this value. Okay, what is the value of the terminal voltage? Okay, so now we can expand this equation since I want to find the value of current that flow in the circuit. Okay, so EMF is equal to IR. Okay, so terminal voltage. So now since we have the resistance, the external resistance is equal to 100 ohm plus the internal resistance in the battery. Okay, so here we have 3. So we can factorize I. So here we have R plus R. Capital R is 100 and small r is equal to, is it 5? Okay, 5 ohm. Therefore, I is equal to 0.0286 ampere. Okay, so this is the amount of current that flow in the circuit. Okay, so the reading of voltmeter is equal to the terminal voltage, Vt. Okay, therefore Vt is equal to IR. Okay, so now it's equal to I 0.02 0.0286 and the resistance is 100. Okay, and it's 2.86 volt. Okay, so this is the answer. Okay, so the terminal voltage or the reading of the voltmeter when the switch is on is the reading of the terminal voltage where it's equal to 2.86 volt. Okay, so finish example 1. Let's proceed to example number 2. Okay, so for question number 2, so now we have a battery, okay, that has an EMF of 9 volt. Okay, so given that the terminal voltage is 8 volt when the battery is connected across a resistor of 5 ohm. Okay, so let's say this is the battery. Okay, so we want to calculate the current through the resistor. Okay, so there is an internal resistance in the battery. So that's why the terminal voltage is 8 volt. Okay, so the EMF of the battery is 9 volt. Okay, but the terminal voltage is given as 8 volt. Mana pergi lagi 1 volt? Okay, 1 volt is the voltage across internal resistance in the battery. Okay, so now this is the external R and this is internal and this is EMF. So given that EMF is equal to 9 volt, okay, but the terminal voltage that across capital R is equal to 8 volt. Okay, so where is the another 1 volt? Okay, you must know that another 1 volt is the voltage that across internal resistance. So I will write as VR is equal to 1 volt. We can write the general equation EMF is equal to V terminal plus VR. So now we want to calculate the current through the resistor. Okay, so how to calculate the current through the resistor? Okay, so for question number 1, okay, so since we know that VT is equal to 8 volt, and the question gives that the external resistance is 5 ohm here. So we know that VT is equal to IR. Okay, VT is equal to IR. So this is capital R, not small r. Okay, so external resistance. So now we can substitute the value where I is equal to VT over R, where VT is equal to 8 volt and the resistance is 5 ohm. Therefore, you akan dapat nilai I. Okay, so where I is equal to 1.6 ampere. So unit jangan tinggal. Okay, so question 2, the power dissipated by the resistor. So we want to calculate what is the power dissipated by the resistor. Remember, so when you want to calculate the power dissipated by the resistor, so please use equation P is equal to I squared R, or P is equal to V squared over R, where V here is the terminal voltage. Okay, let's try these two equations. Kita tengok dapat tak jawapan yang sama. Okay, so P is equal to 1.6 squared, where R is equal to 5 ohm, and the answer is equal to 12.8 watt. Okay, how about this one? P is equal to V terminal, so 8 squared over 5. Okay, cuba awak kira. Dapat tak sama? Okay, mesti dapat sama. Okay, so kita akan dapat 12.8 watt. Okay, so when you want to calculate the power dissipated in the resistor, make sure you use the equation P is equal to IR, current that pass through the resistor. Okay, or you want to use equation P is equal to V squared over R, but remember that the value of V here is the terminal voltage, bukan EMF. Okay, jangan masukkan nilai EMF 9 because the voltage that across R is not 9 volt, so it's 8 volt. So we just substitute VT and it's equal to 8. Okay? Okay, so part 3. So now we want to calculate the internal resistance of the battery. So we have two methods in order to calculate the internal resistance. Okay, since I know that VR is equal to 1 volt, so VR is equal to 1 volt. Therefore, I can write that VR is equal to IR, where the value of I here is the same amount of current that passed through capital R, which is external resistance. So I here is 1.6 ampere. Okay, so when we substitute the value, look at here, we have 1. So this one should be small r. Sorry. So this should be small r. Okay, because internal resistance. So now we want to find R, small r, and it's equal to, okay, I is 1.6 R. Okay, so therefore R is equal to 1 over 1.6, which is equal to, okay, cuba awak kira. Okay, 1 over 1.6, so it's equal to 0.625. Okay, ohm. Okay, or you can write as, okay, here we have EMF is equal to V terminal plus VR. Okay, and from here you know that EMF is 9, I, R plus R. Okay, you can substitute 9 where I is 1.6 and R is 5 ohm plus R. Okay, so if you use this equation, you also get the same value of internal resistance R. Okay, therefore R you akan dapat 0.625 ohm. Okay, so finish example number 2. Let's proceed to example number 3. Okay, example number 3. The EMF of a battery with internal resistance is 12 volt. So given that the EMF is 12 volt. Okay, so EMF is equal to 12 volt. So when an unknown resistor R is connected to the battery, the current is 0.8 ampere. Okay, the current flow is 0.8 ampere. Okay, when we have a circuit, okay, so the battery with the internal resistance R, and when the circuit is connected with the internal resistance capital R, so this is the EMF. Okay, so given that the current flow through the circuit is 0.8 ampere. Okay, so now if another resistor R is added in series, the current now become 0.6 ampere. Okay, so let's draw another circuit. So we still have the same EMF with the same internal, but now we have another R here. So R here and R here, and this is internal and this is the EMF, where the EMF is 12 volt, but now the current that passed through in this circuit is not 0.8 anymore, it's 0.6 ampere. Okay, so calculate the value of the resistor R. So we want to calculate what is the resistor R. Okay, so look at to these two figures. So we have figure A and this is figure B. Okay, so we have two condition here, A, so I want to use yellow. So we have A and B. Okay, so now let's write the equation of the EMF for figure A first. So since we know that EMF is equal to, let's say I want to use blue color. Okay, so EMF is equal to I R plus R. or you can write as EMF is equal to V terminal or V across R plus VR pun boleh. So EMF, so from here we're going to have EMF is equal to IR plus IR. Okay, so we just simplify. So kita akan dapat macam ini. Okay, so where the EMF is 12 volt, the current in this circuit is 0.8. We don't know what is the value of R, and also internal. We also don't know what is the value of internal resistance for small r. So now we have two unknowns here. So let this as equation number 1. Okay, so let's get the second equation from the second figure, which is figure B. Okay, so from figure B, okay, so let's write EMF is equal to I R total plus R. So for this part, look at here, okay, I put R as R total. Kenapa R total? Because we have two combination of external resistance in series, where R total is equal to R plus R, and it's equal to 2R. R plus R, and it's equal to 2R. Okay? So now, EMF here is still 12 volt, but the current here is 0.6. Okay? And R total here is 2R plus R. Okay? So let's try to solve these equations. So second equation here. So now let's insert equation number 1 into equation number 2. Okay? But before that, I want to simplify equation number 1 first. Okay? So based on this one, okay, let's write 12 divide 0.8. Okay, this one should be R plus R. So therefore, small r is equal to 15 minus R. Okay, so I let this as equation number 1. Okay, so now let's substitute, okay, equation number 1. Let's substitute equation number 1 into equation number 2. Okay, where R is equal to 15 minus capital R. So 12 minus 12 equal 0.6, 2R plus small r is equal to 15. Okay, 15 minus R. Okay, so 12 divide 0.6, so you will get 20 equal to, so 2R minus R is R plus 15. Okay, therefore, let's solve for R. The external resistance is equal to 5 ohm. Okay, so this is the answer. Okay, the value of the resistor R. So now, we're going to calculate what is the internal resistance of the battery. So for these two cases, we still have the same battery with the EMF of 12 volt. Okay. So for the second part, okay, so from equation 1, I will write R is equal to 15 minus R, where R is equal to 15 minus 5. Okay, so since R from the previous answer is 5 ohm, so we can straightly calculate the internal resistance, where R is equal to 10 ohm. Okay, so the internal resistance is 10 ohm. And calculate the terminal voltage of the battery. Okay guys, so remember when we have two cases here, ingat lagi tadi figure A kita ada satu saja resistor, okay, here, but for figure B we have two resistance that combine in series, okay, where R total is equal to 2R, tapi yang ini dia adalah R. So when we want to calculate the terminal voltage of the circuit, we need to consider the total resistance that connected in this circuit. Ada berapa R? Okay. So now, let's say for figure A, Okay, so for figure A, okay, V terminal is equal to IR. So we just have one R. Remember, where I is given from the question is 0.8 and 5 ohm is the value of resistance for the external resistor. Okay, so VT is equal to 4 volt. Okay, but for figure B, sebab soalan ni tak bagi tahu kan dia nak, so kita kira terminal voltage untuk A ke B, so kita kira dua-dua lah. For figure B, now V terminal is equal to IR total. So here I highlight R total because we have 2R in series. Okay, so we can substitute I is not 0.8. For figure B, remember I is equal to 0.6 and R total is 2R. Okay, remember it's 2R. Therefore, the V terminal is equal to 0.6 times 2 times 5. Okay, so 0.6 times 10. So V terminal now is equal to 6 volt. Okay, so we finish question number 3. Let's proceed to example number 4. Okay, now example number 4. Okay, look at this question where this question is from subtopic 8.5, okay, which is under subtopic combination of resistor in series and parallel. So this is very simple question. Okay, so when you want to calculate or you want to solve a problem that related to combination of resistor in series and parallel, make sure you consider, okay, the correct rule for resistors that combine in series and resistors that combine in parallel. Okay, apa maksudnya? Okay, when the resistors combine in series, okay, I total is equal to I that pass through R1 and also R2. Let's say we just have two resistors. Okay, but for the voltage, the V total is equal to the total of voltage that across R1 and plus voltage that across R2. Okay, and for the resistors that combine in parallel, okay, the total current that flow in the circuit is the total current that pass through R1 and R2. Okay, but the voltage or the voltage supplied to the circuit is equal to the voltage that across R1 and also the voltage that across R2. Okay, so let's say this is the circuit, the combination of R1 and R2 in series. Okay, and this one is R1 and this is R2. So this is in parallel. Okay, so the voltage that across, so let's say this is 2 volt. So the voltage that across R1 is also 2 volt. And the voltage that across V2 also equal to 2 volt. Okay, but for the series combination, okay, the current that pass through in the circuit, let's say I is equal to 1.0 ampere. So the amount of current that pass through R1 is also 1.0 ampere. And this is also 1.0 ampere. Okay, so let's try to solve example number 4. Okay, deduce the current that flows in every resistance of 8 ohm, 3 ohm and 6 ohm in the following figure. And then calculate the potential difference across 3 ohm resistor. Okay, so let's draw the circuit first. So we have the battery and R1, okay, and this is R2. and this is R3. Okay, so let's label. So 12 volt. So I like to put as R1. So bila saya dapat soalan, saya suka letak numbering dekat resistor tersebut. So this one is R1, 8 volt. And here we have R2, which is 3 ohm. Sorry. So here we have R1, which is 8 ohm. And here we have R2, which is 3 ohm. And here we have R3, which is 6 ohm. Okay, so look at here. Current must flow from positive terminal to negative terminal. So this is the flow of current. You can look at here. So I pass through R1. Okay, and when the current reach the junction, you can look at here. The current split into two parts. Okay, so saya tukar color. So this is another I. Okay, let's say kita namakan sini adalah tadi yang warna kuning ni I1. So the yellow color is I1 and the first is I2. Okay, and this is I3. Okay, so look at here. When the current split into two parts, I2 and I3, means that, okay, R3 and R2 is not in series. Sebab current mereka tak sama. Okay, the amount of current flow through R3 and R2 is not equal. Okay, so means that here we have the clue that R3 and R2 are in parallel. Okay, so we can write as R2 and R3 parallel. Okay, so this one. So when R2 and R3 are parallel, so I like to guide myself. Okay, when I try to answer this type of question, I will put that, okay, since they are parallel, so V23 must be equal to V2 must be equal to V3 because they are parallel. So when we combine 2 and 3, so we are going to get V23, right? So now V23 is equal to V2 is equal to V3. And I also write I23 is equal to I2 plus I3, where I23 is the current that flows through the combination of R2 and R3. Okay, and it's equal to I2 plus I3. So saya suka tulis macam ni untuk guide diri saya bila menjawab soalan resistors in series and parallel. Okay, so what happened when R23 is combined? So let's draw the pattern of the circuit. Okay, so now the circuit will become like this. So this is the battery. Okay, so we have R1 here, and here is R23. Okay, so this is the flow of current. You can see here no junction. Therefore, the current that passed through R1 is equal to the current that passed through R23. Okay, remember? Okay, so now we can write here that R1 and R23, okay, R1 and R23, they are in series. Okay, so when they are in series, means that I total, bila kita kira I total nanti, so it's equal to I that pass through R1, I1, and it's also equal to I that pass through 2, 3, R23. Okay, because they are in series, right? Okay, and second, I will write about the voltage, where the total voltage must equal to voltage across R1 plus voltage across 2, 3. Okay, so yang purple color ni untuk memudahkan saya, untuk guide saya bila saya buat calculation. Okay, now let's start our calculation. Okay, let's find first what is the total resistance in the circuit. Kenapa kena kira total resistance dulu? Sebab kita nak kira current, total current. Okay, kita nak kira ini, I total. Okay, sebab V total is equal to I total R total. Okay, so since we want to find I total, okay, what is the value of I that passed through the circuit? Okay, we want to find R total first. Okay, ataupun equivalent resistance in the circuit, ataupun total resistance. Okay, so now let's try to calculate R. Okay, so R23 are in parallel. So saya akan tulis 1 over R23 since they are in parallel, where 1 over R2 plus 1 over R3. Okay, so 1 over R23 is equal to R2 is 3, R3 is 6. Therefore, okay, R23 you akan dapat nilai dia. Okay, remember this is 1 over R23. So bila you total up yang ini, okay, you kena terbalikkan lah. Dia akan jadi 1 over answer yang saya highlight dengan warna kuning ni. Okay, so this is 1 over R23. Therefore, R23 is equal to 2 ohm. Okay, so kita dah dapat R23 is equal to 2 ohm. So now we want to calculate the total resistance. Okay, therefore, R total, okay, because R1 and R23 are in series, so we can calculate R total, okay, is equal to R1 plus R23. Jangan terbalik dengan kapasitor. Okay, R1 plus R23. So R1 is equal to 8 ohm plus 2. Therefore, R total is equal to 10 ohm. Okay, so kita belum lagi dapat jawapan sebab jawapan soalan tanya current that flows in every resistance. Kita nak cari I yang lalu dekat R1 berapa, I yang lalu dekat R2 berapa, and I yang lalu dekat R3. So now bila kita dapat R total, okay, so saya akan kira lah. So I total, okay. Sekejap ya. Kecilkan sikit. Okay, so I total is equal to V total over R total, where V total is the amount of voltage supplied to the circuit. Okay, so it's equal to 12 volt over 10. Therefore, I total is equal to 1.2 ampere. Okay, sekarang saya dah dapat I total. Okay, so saya get back to our notes here, yang warna purple sini tadi. Okay, so I total, okay, is equal to 1.2 ampere. So get back to our notes, okay, in purple color here, where I total is equal to I1 is equal to I2. So from here, okay, I can straightly find what is the value of I1. Okay, so we can write since I total is equal to I1 equal to I23. Therefore, saya dah dapat jawapan yang pertama untuk I1 and it's equal to 1.2 ampere. Okay, so this is the answer untuk current yang lalu dekat R1. Okay, so now based on this information, I want to find what is V23. Okay, so why I want to find V23? Okay, because we know that for V23, okay, kita tengok notes kita balik. Okay, tengok dekat sini Okay, tengok balik notes kita here. Kenapa saya nak cari V23? Sebab saya nak kira voltage across V2 dengan V3 supaya saya boleh cari current. Okay, so saya terus turun ke bawah. Okay, from here, okay, kita ada I23. Okay, so now let's find V23, where V23 is equal to I23 R23. I23 dah ada ke belum? Dah. Okay, di mana I23 is equal to 1.2 ampere. Okay, so we can write as I23 is 1.2 ampere and the resistance R23, kita dah kira tadi, R23 is equal to 2. Therefore, V23 is equal to 2.4 volt. Okay, so V23 is equal to 2.4 volt. So now kita belum lagi menjawab soalan. Okay, kita nak kira current. Therefore, okay, kita boleh tulis. Sekejap So sekarang kita boleh tulis since V23 tadi parallel kan? So V2 dengan V3 parallel. So therefore, V23 is equal to V2 is equal to V3. Okay, so we can write I2. Okay, we can write I2 is equal to V2 over R2. Okay, I3 is equal to V3 over R3. Okay, so sekarang V2 nak dapat daripada mana? Inilah tadi, V23 dah dapat 2.4 and they are 2.4 volt. Same goes to V3. Okay, so you can substitute. V2 is 2.4 but R2 is equal to 3 ohm. So kita dah dapat jawapan kita, I2 is equal to 0.8 ampere. Okay, so kita dah dapat jawapan yang kedua. Okay, and for this one, I3 is equal to 2.4 but R3 is equal to 6 ohm and I3 is equal to 0.4 ampere. So ini jawapan kita yang ketiga. So kita dah menjawab soalan lah. Kita dah cari I1, I2 dan I3. Okay, boleh? Okay, good. Okay, now for part B, calculate the potential difference across the 3 ohm resistor. So berdasarkan labeling kita tadi, 3 ohm resistor kita adalah here, R2. Okay, maknanya kita nak menjawab soalan R2 lah, V2. Kita nak kira potential difference across V2. Sorry, R2. Okay, so dia adalah V2. Okay, so B, sebenarnya kita dah ada jawapan dah. Kita just tulis balik. So for B, so calculation as above. So bila jawab exam, ditulislah. Ataupun ditulis balik jawapan yang tadi. Pun boleh Calculation as above. Okay. So since V23 equal to V2 equal to V3, where it's equal to 2.4 volt, therefore V2, okay, or voltage or the potential difference across the 3 ohm resistor, you boleh tulis dalam bentuk ayat lah, is equal to 2.4 volt. Okay, so the potential difference, okay, kita tulis, so the potential difference across the 3 ohm resistor, okay, is equal to 2.4 volt. Okay, so kita dah jawab soalan. So finish example number 4. So let's proceed to example number 5. Okay, so let's continue example number 5. So in example 5, we are going to apply Kirchoff rules. So referring to the circuit shown, calculate the current I1, I2 and I3. Okay, so the question gives us the direction of current, where here is I1. So this is I1. Okay, and we have I2 here. So this is given by the question. and here we have I3. Okay, so before we start, I want to label all the resistors in the circuit so that it's easier for me to explain which circuit is related to the equation that I will explain to you. Okay, so now I want to label here as R1, here is R2, and this is R3. So we have R4 here, where R4 is 10 ohm, and let's say this is R5, and this is R6, and the last one is R7. Alright, so as we know, there are two rules in Kirchoff rules. Okay, so the first one, so let's just revise. Okay, the first rule is at any junction. Okay, so we are going to look at any junction. Okay, we need to write the total current in, which is the direction of the current that flow into the junction is equal to the total current out. Okay, the flow of current that out from the junction. Okay, for the second rules, okay, so from second rules we can write two equations based on the loop of the circuit. Okay, and the rule is in a closed loop, okay, total EMF in the loop is equal to total IR. Okay, so now let's write from Kirchoff. Okay, from Kirchoff first law. Okay, so total current in is equal to total current out. Okay, so this is the first rule. Alright, so at any junction, okay, so now let's look at here. We have two junctions here. Okay, this is the first junction, and this is the second junction. Okay, so let's say I choose junction A as my reference. Okay, look at junction A. Okay, you can see here, okay, I1 will flow into the junction. I1 will flow into the junction. Okay, but I2 and I3, okay, you look at here, the flow of current of I2 and I3 are out from the junction. So we can write as I1, since I1 flow into the junction, is equal to the total of current that out from the junction are I2 plus I3. Okay, so this is our first equation from the first rule. And from the second law or second rule, okay, from the second rule, we need to consider two loops here. Okay, so the second equation is based on the first loop of the circuit, and the third equation is based on the second loop of the circuit. Okay, so now let's write loop 1. Okay, let's focus on loop 1 first. Okay, and the equation must refer to the second rule, which is total EMF in loop 1 is equal to total IR. Okay, current times the resistor in the circuit. Okay, so we refer to loop 1. Okay, so this is about loop 1. Okay, so now let's refer to the first loop. Okay, so before we start, let's look at to the EMF. Okay, let's say this is EMF 1. Okay, where EMF 1 is equal to 30 volt. So as we know that current must flow from the positive terminal of the battery for the flow of current of the EMF. So for the second step, I will draw the direction of the flow of current for the loop. Okay, so let's assume the flow of current in this loop is in this direction. Okay, which is clockwise. Okay, since in the first loop, we just have one EMF, which is 30 volt. Okay, and you can hear the direction of the current from the EMF is upward. So I will follow this direction in order to determine the direction of my first loop. Okay, which is clockwise. And how about the second loop? Okay, so here we have two EMF. Okay, so here we have, this one should be E2, and this is EMF 3, where EMF 3 is 10 volt and EMF 2 is 20 volt. Okay, so if you look at to the flow of current for EMF 2, it should be flow from the positive direction. Okay, so I just draw the small arrow to guide me in order to determine the direction of my loop. Okay, but for EMF 3, okay, positive terminal here, and the flow of current from the EMF should be like this. Okay, upward. Okay, so now I'm going to determine what is the direction of my second loop. Okay, let's assume the direction of the current. Okay, so since, okay, let's compare the value of the EMF in the second loop. Since the second EMF is 20 volt and the third EMF is 10 volt, so I will follow the direction of the current from the second EMF, since the value of the second EMF is bigger compared to the third EMF. Okay, so now the second EMF, you can hear the small arrow here. Okay, the direction of the current is to the right. So I would choose the flow of current from the second EMF, since the second EMF here, okay, has the bigger value of EMF compared to the third one. Okay, so let's draw our second loop. Okay. Okay, sebenarnya tak kisah pun you nak pilih direction of your loop is clockwise or anti-clockwise. Okay, but for me, I prefer to choose the direction of my loop that follow the direction of the current in the bigger EMF. So, kalau loop tu ada dua EMF, so saya akan pilih EMF yang lebih besar untuk guide saya sebagai direction untuk kita lukis kita punya loop. So, look at here. Direction of the current should flow from the positive terminal and it's to the right. So, saya punya loop saya adalah clockwise. Okay, kalau you nak buat anti-clockwise pun tak ada masalah. Yang penting you punya positive dengan negative sign bila you substitute in the equation mesti betul. Apa maksudnya? Okay, let's try. Okay, now let's refer to loop 1 first. So, we just have one EMF. So, now you can see here that the direction of the small arrow and the direction of your loop here is the same direction. So when it's same direction, so it's positive. Okay, so the EMF is positive 30. Alright, and total IR. So now refer to the circuit, the first loop. Okay, how many resistors that we have in the first loop? 1, 2, 3, and 4. Okay, and you must focus on the type of current that flow through R1, R2, R3, and R4. Where current that flow through R1 is I1. Okay. The current that flow through R2 is I2. And here we have the flow of current that flow through R3 and R4 is I1. Okay. So look at here, we have a junction. So at this junction, I1 is the combination of current 2, I2, and I3. So this is I3. And this is also I3. Okay. So now, let's write our equation for the first loop. Okay. So R1, I1. So let's say I will write first IR, I1, R1. Okay. And it's positive since the direction of the current I1 and the direction of my loop is the same direction. So it's positive. Okay. And plus, look at here, I2 direction of I2 is downward, and this is also the direction of my loop. They are in the same direction, so still positive value. So plus the flow of current in R2, okay, so I2 pass through R2, so it's I2 R2, okay, and plus same goes to here. We have I1 that passed through R3, and the direction of current I1 and the loop is the same direction, so it's positive. Okay, so positive I1 R3 plus, okay, so here we have R4, where the current that passed through R4 is I1. Okay, so here we have I1. Okay, and look at here. Okay, the flow of current I1 is clockwise, and I1 is here is upward. Same goes to this one. This is also clockwise. Okay, so it's positive value plus I1 R4. Okay, so now let's substitute the values. Okay, so we have 30. So I1 R1, so R1 is 10. 10 I1 plus 10 I2 plus 20 I3 sorry, and plus 20 I1 plus 10 I1. Okay, so we can total up all the I1. Okay, so it's equal to 30 is equal to 10 plus 20 I1 plus 10 I1, so it's 40 I1 and plus 10 I2. Okay, so this is my second equation from the first loop. Alright. Okay, so now let's focus on the second loop. Okay, so it's loop 2. Okay, so let's consider second loop. Okay, so now same goes to the first one. Total EMF is equal to total IR. Okay, and let's highlight first. This is from the second rule. Okay, second Kirchoff second rule. Okay, and let's focus on the second loop. Okay, so we have two EMF, so we need to total up these two EMF. So E2, so the direction of current here, the small arrow that we have here is the same direction with the loop. So it's positive 20 plus, okay, refer to this one, the flow of current from EMF 3 should be upward, right? But the direction of our loop yang kita assume tadi, it's downward. So they are opposite direction. Therefore, EMF 3 should be negative sign. Okay, so it should be positive 20 plus. So we total up EMF 2 and EMF 3. So plus 20 plus negative 10. Okay, why it's negative? Okay, again, I repeat. So this is negative because the flow of current that supposedly come from EMF 3 should be upward. Okay, but our loop here is downward. Okay, so they are opposite direction. So the sign for EMF 3 should be negative. Alright, so how about the current? Okay, look at here for R5. Okay, the flow of current, the direction of current I3 is to the right. Okay, where the direction of I3 is the same direction with the loop. So I3 R5 is positive. Okay, this one should be positive value nanti masuk dalam equation. Same goes to here, R6 and I3. Okay, same direction, downward and downward. Okay, they are clockwise direction. Okay, so this is also negative. Sorry, this is also positive. And R7 is also positive value. But for R2, okay, for the second loop, we have another one where R2 here, the current that flow through R2 is I2, right? But the direction of I2 is downward. But here, the loop is upward. Okay, so they are opposite direction. So the value of IR, I2, R2 should be negative value. Okay, so now let's try to substitute in the equation. Okay, so we have, okay, I3 and R5. So it's positive 10 I3 plus, okay, 20 I3 plus 10 I3 plus negative. Why negative? Okay, again, because I2, okay, because I2 here and R2 is opposite direction. Okay, with the direction of our loop here. Okay, here is downward and here is upward. So negative. Okay, so let's highlight here. So negative. So negative 10 I2. Okay. Okay, so now let's rewrite the equation. So 20 minus 10, it's 10 equal to 10 I3 plus 20 I3 plus 10 I3. So it's 40 I3. Okay, minus 10 I2. And this is our third equation. So now let's substitute all the equations in your calculator. Okay, so before we substitute the values, okay, let's draw a table, okay, in order to guide you which value for x, y, z. Okay, so here we have, okay, look at here. Okay, so this is for I1, I2, I3, and this is for the constant. Okay, so from equation 1, so we have I1 equal to I2 plus I3. So please rearrange this equation. So the equation will be I1 minus I2 minus I3. Okay, and it's equal to 0. So let's substitute here. I1 is 1, I2 is negative 1, I3 is negative 1, and equal to 0. Okay, and for the second equation, we have 40 I1. So let's use another color. So 40 I1 plus 10 I2 equal to 30. So I3 is equal to 0. I1 is 40. Okay, I2 is 10, positive 10. I3, no I3, right? So it's equal to 0 and it's equal to 30. Okay, so the last one is equation number 3. So we have negative 10 I2 plus 40 I3 equal to 0. Okay, so in the third equation, the red one, the red color, so no I1, right? So it's equal to 0. I2 is negative 10 and I3 is 40. Okay, and it's equal to 10. Okay, so now take out your calculator and please insert all these equations in the equation mode. Okay, pilih yang ada 3 tu lah. Kalau calculator baru, dia akan keluar X, Y, Z equal. So X tu masukkanlah 1, Y is negative 1, Z1 is negative 1 equal to 0. Okay, X2 is 40, Y2 is 10, Z2 is 0 and then it's equal to 30. Okay, kalau guna calculator lama yang warna hitam tu, bila you pilih equation mode, okay, 3, mode 3, you akan keluar, you akan nampak ada A1 and then you substitute lah. A1 is 1, B1 is negative 1, C1 is negative 1. Okay, and D, dah ada sampai D kan. Okay, so D is equal to 0. Okay, and A2 is 40. Okay, so B2 is 10, C2 is 0, and D is equal to 30. So awak masukkan semua nilai, and then you tekan enter dan enter. Finally, you will get the value of X. Dia akan keluar X is equal to 0.66 ampere. Y is equal to 0.33 ampere and Z is equal to 0.33 ampere. Okay, so based on this equation, so X, Y, Z, so this is the value for I1, where I1 is equal to 0.66 ampere. Okay, now I2 is 0.33 ampere, and I3 is 0.33 ampere. Okay, so let's say the question asks us to find, okay, what is the potential difference, okay, what is the potential difference across R3, okay, so what is the potential difference across R3? So now look at here, this is our R3, right? So the current that flow through R3 is I1, okay, and if you want to find what is the potential difference that flow through R3, okay, kalau soalan tanya lah, okay, soalan ini saya tambah sendiri soalan. So let's say we want to find V3, which is equal to I1 R3. I1 is the current that flow through R3, right? So I1 yang kita dah kira tadi, it's equal to 0.66 ampere, and R3 is 20 ohm. Okay, so take out your calculator and let's calculate the answer. Okay, so the answer is 13.2 volt. Therefore, the voltage that across R3 is equal to 13.2 volt. Okay, so finish question number 5. Okay, so for question number 6, I will show you the solution, alright, without the explanation. So I think you can try first and you can check your answer here. Okay. So see you in the next video, which is chapter 3 extra examples, okay, on part 2. Okay, so we have several questions to discuss. Okay, so yeah, see you when I see you. Okay, bye. Assalamualaikum dan selamat sejahtera.